Recursive methods and algorithms. This is a quick introduction with some visual examples in Greenfoot on what recursive methods and algorithms are and what we can do with them. But first off, let me start showing some examples of recursion in nature. So recursion is when we do something and then repeat that within what we've already done. So we can, for example, see here we have some kind of cabbage on the left side here, and on the right side we have a flower. What we can see on the left side is we have this kind of pattern where things are progressing in size downwards in a spiral, and if we look into each one of these are actually a copy of the big one here. So we can see we have a structure here that has increasingly sized lumps on it in a specific pattern here, and if we look on each of the lumps, they actually have the same pattern going on, and probably if we look closer we could find maybe somewhat of that pattern. What's special about recursion is in nature is that at some point this must stop. Of course we cannot keep repeating the same pattern forever, because at some point the details will be at some atom level or something like that, and we cannot keep repeating the pattern. But there is some finite amount of levels that we can keep going down and see the same pattern. Here we can also see something that looks like a sort of recursion, where we have these kind of lines where they're progressively larger. We don't have this kind where it's going, we have the same pattern within itself, but we do have some kind of pattern here. So we see this other places in nature as well, where we can see the same patterns. There's a lot of different patterns in nature. Another place where we've seen this kind of idea, where I think maybe a lot of people can relate to this, is in the movie Inception. So if you've seen this movie, it's all about living in the real world, in reality, and they can submerge into a dream world that is one level below the world they're already in. And time is a lot slower on the lower levels, meaning, or faster if you will. So the time here, maybe 1 hour in this level, is only 1 second or a minute in this level, and this keeps on going as you go levels down. So here he goes down one level, and from this level he goes a level further and a level further and a level further. And we see this kind of thing in recursive algorithms as well. Maybe it will make more sense when I start showing examples of this. But you can think of it like we have patterns or things that repeats itself within itself in nature. And we also have these kinds of levels where we can go deeper and deeper into recursion. We can see recursion in other places. These are some examples I found online of ways to generate trees using something like recursion. The first one here, we see there's just like a stick. And if we take that stick and on that stick we put smaller sticks, which is a copy of this one, like smaller ones, copy and make them smaller and put them at an angle like this, we get something, a small stick with some branches on it. And now for the next one we do the same thing again, but this time we do it for the branches as well. So now we put branches here, 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 etc. So we see we put small branch and so forth, and then we do that again and we do it again, and we have something. You've probably seen something in nature that looks like this. So this is a repeating pattern you also see in trees. Here's some trees where you can change some, like the thickness of the branches. You could create something like that here as well. This is just to show that it can also be done in 3D. This is also an example of a tree-like generator, And in this case, we create a branch and we branch out from that branch and we branch out from that again. And I'll actually show a programming example in Greenfoot on how to do something like this, because it's pretty interesting and pretty straightforward and simple once you get to understand it. So we also see these kinds of things simulated in nature. We also see recursion in math in things like fractals. You've probably seen this one before. We can do fractals like this, where we have one iteration and then the second. So we have this pattern here, and we repeat this pattern in a smaller scale on each of the line on the big pattern, and we can get something like this. Here is the Sierpinski triangle, which is you have a triangle and then you divide that into three, like this, 1, 2, 3 triangles, or you can think of it like you just put a white triangle in the middle. And then you repeat so that these triangles look like the big triangle. So here we have 1, 2, 3 white in the middle, 1, 2, 3 white in the middle. So it kind of repeats itself within itself, within itself, within itself. And you can imagine you can keep going on like this forever. So if you look at this broccoli-like cabbage thing we saw before, this recursion, these levels, or these, just like in inception, just like in Inception, we keep going deeper and deeper, and things are getting more and more complex compared to the level before that. So we see this in math. This is another example where we have a circle, and within that circle we put a circle here, and we put smaller circles which gets gradually bigger and then small again, and within all of those circles we do the same thing and we get this very beautiful pattern like this. So all of these things, we can create these in Greenfoot because Greenfoot is pretty good at math, and we can use the Java math library or something like that, and we could draw stuff. So I want really to show some visualizations of recursion. So what I've done is, this is the first part of a series of videos. So I'm going to go through the first video, the next videos are going to focus on the simplest version of recursion. So what I'm going to do, going to show a normal iterative approach to drawing something like these balloons in a circle. So how do you draw balloons in a circle? I'll show that. I'll also show this is actually done using iteration. So each balloon is drawing the next balloon here, and then we are getting this kind of thing that looks like this one over here, but it's done in a different way. And this will show you the difference between iterative approaches to algorithms and recursive approaches to algorithms, and also show you some of the strength and weaknesses of these two. Then I'll go on to show you an example that I made with some flies, where I have one fly that will actually give birth to 3 flies. Maybe flies will lay a lot more eggs, but in my case, to make it simpler, I'll just make it have 3 fly kits here. And each of these flies will have more flies, and each of these flies will have more flies, and we can kind of see the exponential growth of a recursive function like this. And also this will show you how why we need to have some kind of stop. At some point we need to stop so that the recursion doesn't go on forever, because we have only limited amount of CPU power and also limited amount of memory available on the computer. It's not unlimited, so if we just keep going, the CPU will just hang forever. So we need to stop at some point, and that's an important property of recursive methods and recursion, that we need to understand that we need some kind of stop clause, something that says you have to go to this point and no further, because otherwise things get too big. Then I go to show, for the next thing I'm going to show is this program that I made here, where I have this small fly, and this fly is first flying to this this dunghill here, this big hill of manure or whatever that is, and then it will start giving birth to some more flies, and these flies will give birth to more flies, and these flies will give birth, and they will find each different random spots where they'll start eating this so they can create more flies. And then we can see a more complex recursive method where we have multiple methods involved in creating a recursive method or recursive function. And then lastly, just because it's pretty interesting, I also created this tree creator to show you a simple way of doing trees. Within Greenfoot, we can draw trees like this, and I put some sliders here so we can change different parameters, so we can actually generate any number of arbitrary looking trees, but I'll look more into that. So first off, the video with the balloons, then I go into the flies, and then I go into the dunghill one where it's animated, and then this one at last where it's also animated.